This is a map of California, a region in the United States. In blue, running from the Salton Sea in the south to Cape Mendocino in the north, is the San Andreas Fault. The boundary slices California into two from Cape Mendocino to the Mexican border. This fault keeps the US government and all people residing in California on the edge of their seats, as the San Andreas Fault has a long history of creating high-powered earthquakes. Because of this, the fault is always closely watched. And now a recent discovery in the area has shown that the greatly feared fault is about to crack. When is the San Andreas Fault going to crack? Will California slide into the sea when it happens? Join us as we explore how California's San Andreas Fault is finally about to crack. When massive and powerful earthquakes are being discussed, the San Andreas Fault automatically comes to people's minds, especially those living in California. It is a significant fracture of the Earth's crust in extreme western North America. This fault spans northwestward for over 800 miles. Right from the northern end of the Gulf of California through West California, it then moves right from California and passes seaward into the Pacific Ocean in the area of San Francisco. The San Andreas Fault is greatly feared because of the tectonic movement detected around the fault, as it's been associated with periodic earthquakes said to often develop near the surface along its path. A perfect example Americans wouldn't forget so soon is the disastrous earthquake that happened in 1906. Another one occurred in 1989 but wasn't as severe as the first one. 5 years later, disaster struck again. This time, a more powerful and destructive earthquake happened in the Los Angeles suburb of Northridge along one of San Andreas's larger secondary faults. The fact that these earthquakes happened and affected cities does not mean the San Andreas Fault went through the town. However, communities like Point Reyes Station, Fraser Park, Daly City, Desert Hot Springs, Gorman, San Bernardino, Wrightwood, Palmdale, and Bodega Bay lie squarely on the fault and are sitting ducks. This terrible news about the San Andreas Fault came out when the director of the Southern California Earthquake Center, Thomas Jordan, delivered a recent announcement. Indeed, this news would have turned the minds of every Californian and made them almost have their hearts in their mouths. Thomas announced that the San Andreas Fault seems to be in a critical state, and as a result, a great earthquake could be looming underneath. In some ways, the news about this looming earthquake might not have surprised the Californian residents, because they see this fault and have the fear in their minds that it could unleash at any moment. However, the new warning that made them even more scared is that Southern California's section of the fault could give way at any point. In the words of Thomas, he said that areas looked locked, loaded, and ready to go. This announcement was made during the National Earthquake Conference, which took place in Long Beach. The last time the South San Andreas region suffered such a disaster was in 1857, when a magnitude 7.9 earthquake ruptured a breathtaking 185 miles between Monterey County and the San Gabriel Mountains close to Los Angeles. And according to Thomas Jordan, he noted that the fault has been quiet, too quiet. He commented, "The springs on the San Andreas system have been wound very tight, and the Southern San Andreas Fault in particular looks like it's locked, loaded, and ready to go." Although this section of the San Andreas Fault is not the only one overdue for an earthquake. In San Bernardino County, around the southeast at the Cajon Pass, the fault has not significantly moved since an earthquake in 1812. When the area's southeast towards the Salton Sea was inspected, it showed that it had been quiet from about 1680 to 1690, but that is not even the problem. The problem is that scientists and geologists have researched the movement of tectonic plates, and they noticed that the Pacific Plate is moving northwest of the North American Plate. This movement shows that earthquakes should relieve about 16 feet of accumulated plate movement every 100 years. Still, the case is different for the San Andreas Fault, as it has not eased the stress that has been building up for over a century. This is why Jordan advised that California's government should focus on becoming vital to a potentially powerful earthquake, one as tough as a magnitude 8. He also used Los Angeles as an example and praised them for executing a plan to help their vulnerability to earthquakes by incorporating earthquake retrofits on apartment and concrete buildings. Mayor Eric Garcetti pushed this plan into law, and Jordan was quite surprised at the development. He said in a statement, "It's remarkable that this happened. We know politically how difficult it is to make these changes." Other areas that are being focused on include strengthening Los Angeles' unsafe aqueduct systems and its telecommunications networks. But now that the San Andreas Fault is finally about to crack and California is not well prepared for it, what should be expected? An earlier U.S. geological survey was once taken, and the reporters warned that a magnitude 7.8 earthquake on the southern San Andreas Fault is capable of causing 50,000 injuries, $200 billion in damage, and severe long-lasting disruptions. Among the predicted problems is an estimated 1,500 deaths, and the sewer system could be out of commission for 6 months. This sort of powerful earthquake can cause shaking for almost 2 minutes, with the strongest shaking estimated to happen in the Coachella Valley, Inland Empire, and Antelope Valley. It could also distribute pockets of strong shaking into areas where sediments trap shaking waves, such as the San Gabriel Valley and East Los Angeles. The potential devastation the San Andreas Fault could bring gives a vivid explanation of the earthquake that happened in 1857, which had an estimated magnitude of 7.9. It was so powerful it had to be named the Fort Tejon quake. The name is somewhat misinterpreted because the earthquake began farther north in Parkfield in Monterey County. Then it moved south on the San Andreas for an estimated 185 miles through Fort Tejon near the northern edge of Los Angeles County. Afterward, it swerved east toward the Cajon Pass in San Bernardino County, close to an area now known as the 15 Freeway. The Fort Tejon quake was so powerful to the extent that the soil liquefied. This rare and disastrous phenomenon caused trees as far away as Stockton to sink. Trees west of Fort Tejon were also uprooted, while the terrible shaking lasted 1 to 3 minutes. Although the San Andreas Fault spans directly into Los Angeles, it is 30 miles away from downtown, and that is sort of bad news for the city. As a result of the San Andreas Fault system being around Los Angeles downtown, the city is predicted to be significantly shaken by a large earthquake on the fault. To show the amount of damage that this impending disaster in Los Angeles can cause, a simulation of a possible magnitude 7.8 quake on the San Andreas Fault was done by Thomas Jordan and his team. The simulation starts at the Salton Sea and spreads west toward the San Gabriel Mountains while it shows seismic shaking waves bent into the Los Angeles area, Jordan said. Another video shows strong ground shaking stretching from northern San Diego County to Barstow. A similar situation was made in 2010 with a supercomputer, and the Southern California Earthquake Center did it. The center revealed what a magnitude 8 earthquake would look like, and the simulation was made to be like the 1857 earthquake, but stronger. The simulated magnitude 8 earthquake starts in Monterey County but travels farther south, heading towards the Mexican border. In the simulation, the LA Basin and San Fernando Valley would be hit hard because soft soils would trap the shaking in the valley and basin. You can see that this area of influence by the shaking has expanded to huge proportions, Jordan said. You see that big directivity pulse out in front. As that energy is being shoved down the fault, that directivity pulse leads energy into seismic waves that excite the sedimentary basins, like the San Fernando Valley and the Los Angeles Basin and through San Bernardino, Jordan said. You'll notice large shaking in the Los Angeles region persisting for long periods, he said. So assuming the simulation takes place, what type of fault would we call the San Andreas Fault? According to the theory of plate tectonics, the San Andreas Fault stands as the strike-slip boundary between two major plates of the Earth's crust, the Northern Pacific to the south and west, and the North American to the north and east. The Northern Pacific plate is moving laterally past the North American plate in a northerly direction. Hence, the San Andreas is classified as a strike-slip fault. The movement of the plates relative to each other has been about 1 centimeter per year over geologic time, though the annual activity rate has been 4 to 6 centimeters per year since the early 20th century. Parts of the fault line moved as much as 6.4 meters during the 1906 earthquake. However, some still refer to the San Andreas Fault as a transform fault. To get a proper insight into this fault and its meaning, imagine placing 2 slices of pizza on the table and sliding them past one another where they touch along a standard straight edge. This movement would cause bits of pepperoni from one side to crumble across the boundary and drop onto the anchovy side. This is the same thing that happens with the fault, making the geology and landforms along the mighty rift extremely complicated. Some people think that the tectonic plates move fast, but these plates move slowly past one another at a couple of inches a year. This is a speed equivalent to the rate at which your fingernails grow. Despite this slow speed, it is not a steady motion. There are years when the plates will be locked with no movement as they push against one another. So at times, moving a couple of inches a year is the average motion, not a steady one. However, changes also occur whereby the built-up strain suddenly breaks the rock along the fault, and the plates slip a few feet simultaneously. The breaking rocks send out waves in all directions, and it is the waves that we perceive as earthquakes. Although the fault runs underground, it is also visible at the surface. The San Andreas Fault is visible in several places like the Carrizo Plain, also known as the San Luis Obispo County. It can be visible in Marin County as well. However, the fault is easily seen as scarps and pressure ridges. In other places, it is more subtle because the fault hasn't moved in many years and is covered or overgrown with brush and covered with alluvium. In counties like San Bernardino and Los Angeles, a massive part of the roads along the fault are cut through great mountains of the gouge, the powdery and crumbled rock that the moving plates have crushed. The San Andreas Fault's hallmark is the different rocks on both sides of the fault system. As it was formed about 30 million years ago, rocks from great distances have been opposed by rocks from very different locations and origins. The Salinian block of granite in central and northern California emanated in southern California, and some even have their own perspectives saying it is North Mexico. Pinnacle's National Monument in Monterey County is only half of a volcanic complex, the other part being 200 miles southeast in Los Angeles County, referred to as the Neenach Volcanics. There have been myths about the San Andreas Fault, saying it's capable of causing megaquakes. That is not true. Although megaquakes of magnitude 10 or more can happen, scientists agree that they are not likely to happen. An earthquake's magnitude is related to the fault's length on which it occurs. This means the longer the fault, the larger and more powerful the earthquake is. Now, the San Andreas Fault is only 880 miles long, and generating an earthquake of 10.5 magnitudes would need the rupture of a fault way longer than the San Andreas Fault. No fault long enough to cause a magnitude 10.5 earthquake is known to exist. The largest earthquake ever recorded was a magnitude at 9.5 on May 22, 1960 in Chile. The earthquake happened on a fault that is almost 1,000 miles long. Another myth people have embedded in them is that earthquakes can be predicted. That is also false. Earthquake prediction is the holy grail for earthquake scientists, but presently there is no accepted method of how the time, place, and magnitude of an impending quake can be predicted right before it happens. However, research is still ongoing on earthquake prediction, and now scientists have estimated that over the next 30 years, the possibility of a major earthquake happening in the San Francisco Bay Area is between 62 and 60% in Southern California. Scientists can also predict the type of ground motion based on the geology and the history of earthquake activity in the region. Engineers and building code developers use these site response models to enhance structure safety, thereby limiting the ultimate earthquake risk. The San Andreas Fault is more within reach than any other fault in the world. With California's huge population and climate, several roads stretch along the fault. They are uncrowded and peaceful and are also perfect for family outings. There is enough room for camping, bird watching, rock collecting, and natural beauty, with wildflowers and wildlife along the way. As a matter of fact, state and national parks are strung along the fault like beads on a string. And to enjoy the perfect journey, all it requires is a good map, a comfortable car, and a desire to see the world's most famous fault. But this world's famous fault still bothers scientists and geologists with its utter silence, and they have no idea when it would unleash all the stress it's been holding in. Would the next quake coming from the San Andreas Fault be as powerful as the great 1857 Fort Tejon earthquake, or would it be as great as the 1906 San Francisco earthquake? The San Francisco earthquake is one that entire state residents wouldn't forget easily, as it destroyed a huge part of San Francisco and was also felt in most areas of California. But the largest earthquake that was felt all over Southern California was the Great Fort Tejon earthquake on January 9, 1857. One thing people don't know about the Fort Tejon earthquake is that Fort Tejon was not the focal point, nor was it even the earthquake's main point. Surface rupture originated northwest of Parkfield in Monterey County and propagated southeastward for over 360 kilometers along the San Andreas Fault to the Cajon Pass, northwest of San Bernardino. Technically, Parkfield was the epicenter of this earthquake, and as it was the origin's rupture, most scientists would be more concerned with the extent and location of the entire crack. Fort Tejon was approximately the midway point of the rupture. The earthquake actually acquired its name because Fort Tejon was the only populated locality near the fault. Naturally, the fort suffered more damage than the rest of sparsely populated 1857 Southern California. In comparison to the other great earthquakes of historic times, the 1857 Fort Tejon earthquake was more significant than the 1872 Owens Valley quake, and was equally as large as, if not larger than, the 1906 San Francisco earthquake. Estimates for Fort Tejon are also in magnitude 8. The 1857 and 1906 events were on the San Andreas Fault, although the 1906 earthquake ruptured the northern segment of the fault from Hollister northward for 400 kilometers. The duration of shaking along the fault for 1857 and 1906 is estimated to be as long as 2 minutes. In areas away from the fault, such as Los Angeles, San Bernardino, and Santa Barbara, damage from 1857 was surprisingly light, although it's unclear how modern high-rises would respond to the long-period motion experienced at significant distances from large earthquakes. High-rises may be more susceptible to long-period ground motion than low buildings. On the other hand, Fort Tejon suffered considerable damage from the main shock, and it was battered by aftershocks for months and years to come, both a direct consequence of the fort's proximity to the fault. 2 large aftershocks approximated to have magnitudes of 6 to 6.5 occurred within a week following the main shock, which was felt over much of Southern California. However, aftershocks were still being felt weekly at Fort Tejon over a year later, and it's expected that if any other locations along or near the fault, such as Wrightwood, Palmdale, Fraser Park, or Taft, were populated back then, those locations would have reported similar intensities during the main shock to those at Fort Tejon, and those locations could have experienced just as many aftershocks. The 1857 quake was the last so-called big one in Southern California, and a similar event will almost certainly happen again. Questions remain, however, as to when it will occur and whether the next big one will be as big as 1857. Los Angeles appears to have fared well last time, but it remains unclear how modern structures will respond. It turns out that for Los Angeles, San Bernardino, and Santa Barbara, blind thrust faults and other local faults are a bigger risk than the San Andreas fault, simply because the former is closer to the population centers and because we know less about them. But for Fort Tejon, Palmdale, and other cities along the San Andreas remains the most significant threat. Only by continued monitoring and research can we hope to understand and reduce the seismic hazard over Southern California. We can never prevent earthquakes, but by knowing what may happen, we can prepare for them. Do you think the San Andreas Fault will cause more damage than the Southern California Earthquake Center predicted, or will the San Andreas Fault remain silent forever? Let us know your thoughts in the comments section below.